So if we have to go get that problem again, and I don't know if I could call up my page again. We can probably get it from here. Ooh, I hope that's not the right. That's not the right one. You don't want that one. It's for an old final. You can't see that day. Lucky for you, because that's not good. You want the one off of up here. There it is. So it said go get using the equation in number 17. They meant 14. So go get the equation. Oh, it is. It's in 20. Get this equation from number 20, and we're going to work this problem. We're going to do how many grams of water can be made from 34 grams of ammonia. So I'm going to come back up here. So I'm going to take 34 grams of ammonia now. And I want to know how many grams of water. Don't worry about this problem because we've already done it. So 1 mole of ammonia is 17 grams of ammonia. 1 mole of water for every 2 moles of ammonia. And then 18 grams of water in a mole of water. (34/17) is 2. 2 divided by 2 is 1. 1 times 18 is 18 grams of water could be made. Try to make the math kind of easy as well on the final, since it is a final. Just see if you're getting the idea. Now the next one was the dreaded limiting reactant problem, which probably take longer than anything else on a test. And they gave you this time on it, if we look at it, it has 26 grams of ammonia and 35 grams of CO2. So we can revert back to this whenever we need it. We'll go to this one. And so this time we're going to use 26 grams of this. And how many grams of CO2? 35 grams of the CO2. So I'm going to have to work 2 stoichiometry problems to the water. This one to the water and this one to the water. And see which one makes the least. Now I've done that down here at the bottom of the page, I believe. No. I don't know where I did it. There it is. So we'll take the 26 grams of ammonia and divide by 17 grams per mole. And then divide by the mole ratio of 1 to 2 and multiply by 18. And I got 13.76 grams. I did the same thing for the CO2, 35 grams over 44, 1 to 1, 18 grams per mole. And I got 14.31 there. Which one made the least amount? The first one made 13.76. This made 14.31. So the correct answer would be this. This would be the limiting reactant. This one would be in excess. Now they asked me last period, Are we going to have to figure out how much excess? I had to cut some things from the final. That's one of the things that didn't make it. You're glad. Just leave lots of dollars for me at the door, and be fine. Okay? So that's your limiting reactive problem. Work 2 problems, look for the one that makes the least, and that should be your correct answer. So in this case, 13.76 is smaller than 14.31. Are we good on that? Those take a little time to do. I told people, you know what, a good attempt would be if it takes you a while to work math problems. I'd go through the test, do all the ones that don't require any math, and then come back and start doing the math problems. Or if you know it's one you can do real fast, like a mole or volume, do it real fast while you're there. And remember the beauty of it, it is multiple choice, so the right answer is there in every case. I like that. I always liked multiple choice in the sense that, I should know what I'm doing. Okay. Relationships. The relationship between temperature and pressure is a direct one. This is really easy. All of them are direct except for pressure and volume. I can't tell you how many people on the test told me that that P1 over V1 equals P2 over V2. That's not right. It's the only one that is P1 times V1 equals P2 times V2. So remember that. All the others are direct relationships. Then what you're saying, well, what kind of a question would you ask? Well, look at this kind of a question. What happens to the volume of a gas if pressure is constant and the temperature goes up? So volume goes up, or excuse me, if temperature goes up, then volume should go up because it's a direct relationship. Now, of course, we can put the numbers to it. And this is a Boyle's Law problem down here at the bottom. Where P1 V1 equals P2 V2. And we have a starting pressure of 135 kPa and a starting volume of 2 liters, a final pressure of 200 kPa, and they're asking us what would be the new volume. So we'll divide both sides by 200. 135 over 100 is 1.35 liters. Notice how the math was pretty easy there. Dalton's law. Sum of the partial pressures equals the total pressure. In this one, we have a mixture of hydrogen, oxygen, and nitrogen. So the total has to be the pressure of the hydrogen plus pressure of the oxygen plus pressure of the nitrogen. So they give us the total. They give us the hydrogen. They give us the nitrogen. They don't give us the oxygen. So if we add those two up and subtract from 785, I got 404 millimeters.